Combinations are when order doesn't matter. So if we put you in groups in class and I tell you you're all sitting in a group of four, but it doesn't matter which table you sit at, you're still the same group. And if we um, switch you around to different tables, but you're still the same group of four, that's not like a different situation. That's an example of a combination. So I think the most difficult part about this lesson is just figuring out, is it a permutation or is it a combination? Because we're going to pretty much use the same menu on the calculator. It's just going to be the combination button instead of the permutation button for these types of problems. So example one, an ice cream vendor is selling 15 flavors of ice cream and we want to sample 5 of them. And how many different combinations of ice cream can we sample? Now, it doesn't say anything that it matters the order we're sampling them. We're just sampling 5 out of 15. Doesn't matter the order. If I'm sampling chocolate, vanilla, strawberry, and then 2 others, I'm still just sampling that 5 of the day. So there's 15 total at the store. I'm sampling 5 of them, and we're determining it doesn't matter the order I'm sampling them in. I'm just picking 5, so it's a combination. We're going to go to the same menu on the calculator, the probability menu, and we're going to find that by going to your math button first, and then you're going to use the arrow key over to the probability, and it's PRB on the top. And now you're going to go to option 3. Depending on your calculator, most likely you have to put the 15 in first, then do all of this, then put the 5. And at that point, just to make sure you're getting the right answer, we should get 3,003. That's how many combinations we can sample. Okay, the next example would be books reading. Parents having 10 books to read to the children. So 5 of the books are fiction, 5 are nonfiction. And it says the order in which they read the books is not important. So if order is not important, that tells us right there it's a combination because the order is not important. How many different sets of 4 books can they choose? So there's 10 books total. We know it's a combination, and we're choosing 4 of them. So we're going to do the same buttons on the calculator. We're going to go to the same process, map, probability. You probably have to put the 10 in first. It just depends what type of calculator you have. Try it out, and you should end up with 210. Now, this is one of those times in class for option B where I would say, try out B. Try to figure it out. So I would really like you to pause the video before you just see how I do it and try to figure out B on your own. Because if you did that, hopefully you read the rest of the page and you saw this is an or situation. And then we're telling you with probability, if you have or, what we're doing is we're adding. And if we're having events and we're 2 events and it's and, we're going to multiply. So what we're going to do is figure out how many options we have separately, and then we're either multiplying if they're and or adding them together if it's or. So what I mean by that is in this problem, we have how many groups of fiction or nonfiction. So I'm going to almost think of it as 2 separate problems. So first we're going to have how many groups for fiction, and then how many groups for nonfiction. It's a little messy. Let me redo this just like I would in class. Nonfiction. Okay. And if we go back to the original problem, it said 5 books are fiction, so we had 5 fiction, and we would want it to know, let's say all of them were fiction. So all 4 of them would be fiction, and we had 5 total to choose from. And if it was an or, we would have to add to the same situation for nonfiction. And if we could do all of this in our calculator, or you could do them separately and have 5 plus 5, or you could do it all in one line on your calculator, and the answer would be 10 possible combinations. So now we're getting into committees. Committees are pretty common problems for these because when people join a committee, they're all just a group of people on the committee. The order doesn't particularly matter. They might just be 5 people on the same committee, regardless of the order they joined. So that would be a combination. So now we have here 6 seniors, 5 juniors, 4 sophomores, and 3 freshmen. And we want to know how many different committees of exactly 2 seniors and 2 juniors can be chosen. So I would first think of, I'm going to have labels, seniors, and then I'm going to have my juniors. And then I would have 6 seniors total, but I only would like 2 of them on my committee. And for the juniors, we have, 5 juniors and only 2 of them. And this is and. So for and, we need to multiply because it's telling us anytime we have an and situation, we're going to multiply. And on your calculator, we can figure these out. Try it. Hopefully, you're pausing the video, trying out these calculations, and this is going to end up being 150 different possible committees. And now our last problem is at most 4 students. And think about what at most 4 students would mean. And try this one too. Because if we can have a committee with 4 students, that's one possibility. But we can also have a committee, if we can have at most 4 students, we could have a committee with 3 students. We could have a committee with 2 students. And we could have a committee with 1 student. That would be the maximum number of students we could have. So now it doesn't have any, doesn't say how many juniors, how many sophomores. So we would need to figure out our total number of students. And if we add up everybody, we have 18 possible students. So now I would do the same thing I did before. We have 18 students, and this would be our combination with how many combinations we could have with 4. And then I'm going to have you guys think for a moment, are we adding or are we multiplying? And now for 3. And now for 2. And now for 1. And hopefully you determined we're adding these together to have our total of 4,047 different committees.